Hi everyone, welcome to the fourth video in the series of trigonometry revision. Mentioned in the previous videos, a few people have asked for help on how to create diagrams from written problems and how to sort of work their way through the question to decide when to use sine, cosine rules or when to use right angle trigonometry. So these questions are all from your textbook, but they're in no specific order because you don't know on an exam or on a test what you have to do until you've played around with the question. So let's jump right in here. Edwina stands due south of a building 40 metres tall to take a photograph of it. The angle of elevation to the top of the building is 23 degrees. What is the angle of elevation, correct to 2 decimal places, after she walks 80 metres due east to take another photo? Alright, so first thing, let's actually highlight our key information here. So Edwina stands due south of a building, and that building is 40 metres tall. She takes a photograph of it. Don't care that it's a photograph. The angle of elevation to the top of the building is 23 degrees. So we're starting to see that angle of elevation. We remember that angles of elevation are from the horizontal. What is the angle of elevation, correct to 2 decimal places, after she walks 80 metres due east to take another photograph? So I kept reading there, and this actually has our big question hidden in here. There's our questioning word, what. So we want to find what is the angle of elevation to the building after she has walked 80 metres, and we need to find that angle of elevation correct to 2 decimal places. Alright, let's have a go at drawing this diagram. As I always say, start with a point. We need to start a diagram somewhere, so let's actually just put a point on here. Here's my point. This is E for Edwina. Edwina stands due south of a building. So due south, that's just a fancy way of saying exactly south. So here's my building. Fancy skyscraper. There are all the windows. And it's got a tower on top. There you go. Lovely. There's my building, B. Don't need that picture. Actually distracts from the whole diagram, but I'm going to leave it there for the time being. So Edwina is straight south from there. The building is 40 metres tall. So the building is 40 metres tall. And the angle of elevation to the top of the building is 23 degrees. And when I try and put this on my diagram, I notice that, well, how do I, what's going on there? That's a bit funky. I can't really see it. What I'm going to do, I'm going to actually draw that sideways now. I'm going to say, well, hang on, that didn't really work. I'm going to say that this is now Edwina. This is the base of the building. This is the height of the building. And there is the angle of elevation, 23 degrees. So I'm actually going to leave both of those things on there because I'm sort of getting that horizontal side-on view as well as the overview of the whole thing. And I'm going to have to try and put that together somehow through this question. So at the moment, I'm just scribbling some notes to get my thinking happening. After she walks 80 metres due east. All right, so again, we've seen that east, we've seen that south. Maybe you jotted down your little compass to say north, east, south, west when you started this question. So Edwina now walks off this way for 80 metres. And she looks back to the top of the building again. And we want to find out the angle of the elevation to the top of the building now. Right, so the angle of elevation would be for the horizontal. So that line that I'm drawing now, this line here, this line would be the straight line that's on the ground. This line is the line where Edwina looks up to the building. That is the height of the building. And what's here, even though we can't see it, it doesn't look like a right angle, but it's actually a right angle. Because what's happened on the ground is we now have Edwina standing at point 2. So Edwina's now at this second point over here. And there's a distance to the building that's changed. It's not the same as before because she moved. And we want to find out the angle of elevation to the same building. Now, we've created another right angle triangle. So you might want to sort of think, well, how does this work? What's going on? And you might want to try and pick apart a few different bits and pieces here. You might want to try and have another draw of the diagram. So at the moment, I'm looking at this question. I'm thinking, I'm not really happy with either of these diagrams. So I'm going to have a third crack at it. I'm going to say, well, here's the building. Here's Edwina over here, and I'm going to assume that that's south. And the initial angle of elevation is 23 degrees. And that line down the bottom, let's make it green to say that that's the ground. The grass is green, so the ground is green. There you go, that's the ground. That's flat on the ground, flat surface. Then Edwina moves along the ground, so still green, 80 metres to a second point that's over here. And we don't know how far that is, but we now know that she's got a new view of the top of the building. And again, that green line's the ground, so the building's going to be at a right angle to the ground. So it doesn't look like a right angle, but they're actually both right angles in there. And our building's still 40 metres tall, and we want to find out this angle from the ground to a new angle of elevation. So we've actually got 3 triangles here. Let's actually try and draw all of these 3 triangles. I'm going to label some key points though to help me understand what's going on. So I'm going to call this T, the top of the building. I'm going to call this B, the base of the building. I'm going to call the first point that Edwina was at as E1, and the second point Edwina is at as E2. And now let's turn this three-dimensional diagram. So we're working in 3 dimensions here, but we've got a 2-dimensional piece of paper. That can be really tricky. So let's turn this 3-dimensional diagram into a 2-dimensional pictures. So hints. Remember I talked about notation. So 1, start visualizing. Try drawing it. And then 3, try drawing from different angles. Notice I didn't actually rub out any of these pictures. I wasn't happy with it, but I kept it there because that was part of my thinking. It was showing my journey as I went along. I wasn't supposed to get it right the first time. Okay, so for my first diagram now, so now that I've got a better idea of what's going on, create simple 2D diagrams. And to help, I've labelled it with all of these letters. Hopefully my battery doesn't go flat during the video. So my first diagram I'm going to have as, and we already had this one above, but I'm just going to redraw it. We've got Edwina 1, and we have the base of the building, we have the top of the building. We know that the angle is 23 and the height is 40. So we could find out what the distance from Edwina to the top of the building was with this triangle, or we could find out the distance from Edwina to the base of the building. All right. One of those 2 things might be handy. We're going to analyse that in a minute. Second diagram. We had Edwina was straight south of the base of the building. So now if Edwina was straight south of the base, That was where she was at the start. And then she went east 80 metres to the second point. And this point is a bird's eye view. This one is a side-on view. But notice, if I've got straight south and straight east, I've got another right angle triangle. And let's do some colour coding here. This length goes from B to E1. This length is B to E1. So those two things match up. Those two things are the same. So we're starting to analyse and work out which parts match. Let's have a go at the third triangle here, and that will be the triangle from TBE2. And again, this is another side-on view. So we've got top of the building, base of the building, and between the two. We need to find out that angle of elevation from Edwina's second position to the top of the building. And I know that the base of the building to the top of the building is 40 metres. But I don't know what this base length is. But again, what my brain is doing is I'm analysing these pictures as I draw them. That part is the same as that part. So I'm going to start thinking, well, what can I do to put all of this information together? What do I actually need to find? Big question, find the angle of elevation. So let's actually work back from this angle of elevation. If I knew what this length was, I could find that angle of elevation. Because I would have two sides and I can find an angle. So if I knew what that angle was, I could find out the angle of elevation. If I know x, I can find the angle of elevation. But I can't at the moment because I don't know x. So let's move backwards. Let's go back to our previous triangle. This is x. If I knew what x was, that would be great. I might be able to do something here, but I don't know anything. Can't do anything. But from this diagram, could I find out the length along the bottom? Because that length would match this length. So I'm starting to analyse and put together, well, what can I find? And sometimes you don't even know, like you might not be able to think about it in this much depth. You might just say, what can I start with? I'm going to try that and work from there. So you might even just say, oh, I've got this triangle. I can find that length. Let's just find it. All right, but what I'm spotting here, I'm going to find out what y is to get this value. Once I know what y is, I can find out what x is. Once I know what x is, I can find out what the angle is. All right, so let's actually run through that process. Let's find out what y is, then we'll find out what x is, then we'll find out what the angle is. We've got 3 steps, but everything is right angle triangles. So let's work with each of those right angle triangles. And I've run out of space on my page, so I'm just going to move this down. And hopefully we will fit it in here. All right, side view. Let's first find out what y is. Here's my picture. I've redrawn it now again. I know I just copied and pasted, but you can deal with that. Don't try and do these questions in one step. So this one is the opposite. This one is the adjacent. It's a right angle triangle, so I can use SOHCAHTOA. Let's write that down. Right angle triangles. So use SOHCAHTOA. And in this case, I've got O and, don't know why my A didn't join there, SOHCAHTOA. In this case, we've got O and A, so it's going to be tan. So tan theta equals the opposite over the adjacent. Substitute what we know. Tan of 23 equals 40 over y. I now need to undo a divide by y, so I times by y on both sides. Practicing my algebra skills here, y times tan 23 equals 40. And then I need to undo a times by tan. How do I undo times by tan? I divide by tan of 23. And get y equals 40 divided by tan 23. Going straight over to my calculator now. 40 divided by tan 23, and you get 94 meters. Now I actually put the decimal places in there because we needed to go to the 2 decimal places. So if I've got no decimal places now, I'm going to make a rounding error at a later date. Alright, 90.23. Let's move this picture right out of the way. Okay, so now that we've got y, that means that this second diagram, I can actually take the y there and I can replace it with my new value. Let's just copy that. I think I moved the other one. Paste it. So now we've worked out what y is. I can stick it over here. So how did I get to this stage? I tried something and I just started working around my pictures. I started working around my diagrams. While I was drawing all of those pictures, I was thinking about what was happening and how it connected, and that helped me spot it quite easily. Alright, I want to find out what x is now. So to find out what x is, I've got no angles. No angles. All sides in a right angle triangle. So you shouldn't be thinking trigonometry right now. You should be thinking Pythagoras' rule. No angles, don't use trigonometry, use Pythagoras. Okay, so c squared equals a squared plus b squared. And my longest side is always c, and the other 2 sides do not matter which ones we call which. So x squared equals 80 squared plus 94.33 squared. And then to find my answer, I have to undo the squared, which is to take the square root. And I'm going to do this all in one step on my calculator. So square it, and then take the square root of the answer. And I get 123.612. Alright, move on to the third triangle now. I know what x is. So I've been able to work through my problem. I've found out what x is. I know that it is 123.612. So let's copy this diagram here and work with this one. And now I can find out the angle. Finally, the angle of elevation. So it's a right angle triangle. This is the opposite. This is the adjacent. It is tan again. So it's tan theta equals the opposite over the adjacent. I don't know what the angle is. I do know what the 2 sides are. So substitute 40 over 123.612. And then type that into your calculator. Oh, before I type it into my calculator, sorry, screen scrolled. I have to do one more step. I have to undo the tan. Remember when we're finding an angle, I use inverse tan. This is my 4th video in a row and I'm starting to run out of brain space here, folks. I'm making some silly mistakes. So I might have a break after this one. So we do inverse tan of that and we get 17.93 degrees. Now, it'd be really useful to just stop and take a moment. We've done a ton of work on this question, so think about, have I actually answered what was going on? Have I found an angle of elevation? Well, I've got an angle, so that's a good sign. Does my answer make sense? Is it reasonable? Well, it's not bigger than 90 degrees. An angle of elevation wouldn't be bigger than 90 degrees. It wasn't some tiny decimal. The first angle of elevation was 23 degrees. The second angle, if we've moved 80 meters to the side, it makes sense that that angle would be a little bit narrower to me, because we've moved sideways. So to be a little bit smaller than 23 and have an answer of 17.93 makes sense. It seems logical. So that is my final answer of 17.93 degrees. Let's run through it. 3D problems. Don't be afraid to draw them several times. Start with trying to do simple two-dimensional diagrams. You might want to try and create a 3D diagram, but in the end, I come back to side views and bird's eye views of everything to break it down. And then work through it one step at a time. Don't be afraid to take 3 or 4 steps to get your answer. How do I know what steps to take? Sometimes you just try something. You might not know if you're getting anywhere, but in first video we discussed, doing something to get some marks. This might be a case where you might not finish the whole question, but you might get some marks along the way.